I remember your idea that ORKG is a Wikipedia for science, and yeah, I like it. I agree.
Yes. I have a dream of eventually calculate an answer to this discussion.
Yeah, theoretically, I believe it is possible.
Do you think we could eventually automate this?
We can try. The three topics I wanted to discuss. The first thing is the idea of that you can calculate what is true or what is not, and to find the solution in an argument, in a discussion. Another thing is what is the difference between information, knowledge, and data. And the last thing is what is knowledge and a knowledge graph comparing to relational data model.
So given all this, what actually can be known? And I know there's this ladder of data goes to information, goes to knowledge, goes to somewhere. How do all those things interlink? What is information?
Yeah, what a good question. Yeah, I would add also noise in this row of data, information, and knowledge, and maybe above the knowledge would be some already utility, practical utility, and benefits, and so on. But as a knowledge representation, researchers, we are focused on these three data, information, and knowledge. And I would explain the difference between them with the example of machine learning. In machine learning, we have input data, but what is data and what is the difference between data and just noise? I would say that for noise to be data, it requires some kind of structure already. The most used example of data in machine learning are tables, and tables already a structure. You have rows, you have columns. We have time series, for example, but already it is ordered regarding the time. Text, of course, also has some structure. It has words, characters, and so on. We can't do anything with noise. We can just understand what is noise. We can perceive it by our seeing or hearing, but unless we put any structure on them, we can do with it anything. Okay, we have data. Next, what is information? And I have to make a disclaimer. I'm not some kind of state-of-the-art researcher on these notions, and I don't tell any higher order truth. I just express my opinion on difference between them based on my personal experience and current studies. Okay, for me, information, it is already a bit more complex structure where we have particular binary relation between subject and object. And in our example of machine learning, we have input data, which could be considered as subject. And the opposite is, if it is a classification, we have a class label as an object. And the relation between them is what represents the information. We can call it truth, because classification could be correct or can be wrong. We can assign wrong label. This relation already doesn't exist in the universe. In the objective reality, it is a kind of abstract object. So on information level, we can call them sentences, which has true or false meaning. And finally, what is the knowledge? It is a model with which we assign subject to object, with which we produce truth or false information. From another side, we can say that knowledge is an algorithm for compressing information, because knowing the model, for example, some decision tree, we don't have to store the resulting class labels. We can use just input data and our decision tree and to reproduce the labels. Sometimes we even don't need to use all input data. We can say that these features from the input data are not relevant, so we need only those and those features.
So, putting all of this together, an audio file of this conversation is the noise. The transcript is the information, and the message or the learned facts are the knowledge. Learned facts, I guess that is the most interesting part.
Yeah, according to this classification, learned facts are not knowledge because they are just facts, it is information.
Yes.
But some theory that you can get from these facts, which you can, this principle of classification, you can learn it, yes, and produce some new facts regarding this topic.
So my old postdoc kept saying you can't formalize knowledge. And I guess in a way I begin to understand what he meant by this. Not noting if he's right or wrong. But basically, isn't knowledge more of a reasoning skill than an information? And an information is the only thing that we can formalize?
I wouldn't, I even won't agree with this expression that we can't formalize knowledge. I just saying that we can't represent knowledge just in statements, like facts. But there are a lot of ways to formalize knowledge. For example, there is epistemology logic, where we formalize the concept of knowing effect with model operators. Like there are different agents, for example, people that know something. They have accessibility relationship between facts and states of the reality. And according to the model semantics of model logic, possible word semantics, we can deduce that for particular agent, he or she knows something or she doesn't know something, and so on. This is one way. From another perspective, going back to my example of machine learning, the decision tree model is also a knowledge. It is an algorithm. It is not a statement, but it is a more complex structure which includes some tree graph theory, tree grammatic, some properties of the tree, some logical expression in the nodes. So it is quite complex structure, but it is fully formal.
I kept thinking about especially trained large language models, because they are knowledge. You can't read it, you can't extract anything from it directly. It's more like a black box of knowledge. But by giving it a prompt, you see knowledge at work, I guess.
Yeah, that's another interesting question about neural models, like large language models. According with my classification, it is a knowledge because there is some algorithm that converts input data to output data and produces new information, for example. Yes, but another feature of knowledge that we like, that we people like, that it is reproducible in symbolic level, that you can say some to explain some knowledge to another human and he will understand it and can apply this knowledge to other facts. But you can't to translate the neural model to another person because it is quite big. It has billions of variables and values of these variables, and people mind just can't remember it. But you can transfer one neural net to another computer, so it is transferable. So it looks like there is knowledge for people and knowledge for computer, or we can't, or we can say that still it is not knowledge because people can't understand the neural networks. They can't get them into their minds.
If I'm thinking about it a little more right now, information, noise, and data all seem to have a lot in common. It's like things are there and you can look at them, but there's a lot of them around that's not helpful. And then you can extract the more crystallized, the more pure form of it, let's say. So you can convert noise to data by just throwing stuff away that was there previously. You can get information out of data, again, by, let's say, purifying it or clearing or whatever. But I'm now thinking about knowledge more as a term of function, or, as you mentioned, algorithm. So it is not the input and not the output, it is the part in between.
Yeah, this is my point of view.
And that's interesting. Again, the limit of your understanding is your language, right?
And there is another topic that I was going to discuss about what is knowledge in a knowledge graph. I would say that knowledge graph is just a marketing term from Google, historical tradition that it is called a knowledge graph. But if I would name it, I would call it somehow different.
I was thinking of calling it an information graph.
Wait. Of course, it contains knowledge, but it is not the only thing that contains knowledge. I would start discussing it as a graph data model and an alternative for graph data model and relational data model. So I will compare these two models. And of course, graph data model and relational data model, both of them contain knowledge. So we can also call relational databases as a knowledge basis. And people do so, in fact, because, for example, if you apply some first order logic reasoning to knowledge to relational database, it will be already a knowledge base. Both models are compressing data in different ways. In relational data model, we have normalization methods, which allow to decompose your data so it takes less space to store them. And with these entity key relations, we can reconstruct the input data. And so it is also a kind of algorithm that allows to get data, compress them, and to reproduce them. We also can do reasoning with Prolog or other stuff to infer new data from this model. And there is another model in knowledge graphs that is more about relations between particular nodes. And there is another logic behind them, description logic, and it is less expressive than first order logic, but more computable and more stable in some sense. What is interesting for me would be to get some mathematical formula or algorithm that would allow to count how many knowledge we can produce with one data model or another, how good we can compress input data or input information. So for particular data sets, piece of data, we would be able to say, okay, this data would be more efficient to store as a relational database, and this amount of data would be better to store as a knowledge graph.
I have a dream of eventually transcribing a format that's called 13 question. Basically what they do is they have somewhat experts, or let's call them stakeholders for now, so they are somewhat relevant to the question at hand, and they present them with 13 questions. Let's go with where we are right now. Are knowledge graphs, or data graphs? And then you have 3 people for knowledge and 3 people for data that think that one or the other is correct. And then they are having a conversation and talking about it, stating arguments and so on. And if I get your first point correctly, eventually what we can do is transcribe what they said, analyze the transcript, and then formulate correct statements that they made and find, I'm not sure which word to fill in. Consensus here, truth, solution.
If we speak about conflicts between several people, I would call it a solution of a dispute.
Okay, so we could calculate an answer to this discussion.
Yeah, theoretically, I believe it is possible. When we define formally what is information, what is data, what is knowledge, what is graph, what is model, and obviously we will have to say that, okay, this is a graph model.
Do you think we could eventually automate this?
We can try.
I mean,
of course, we can't automate and formalize everything, but we can start with some practically important points and move further.
Okay, so you do the serious task while I mingle with the unimportant. When you just now went into the definitions, I had my fair struggle of hanging on to everything you said, going from data to knowledge. So in a way, that is also the reason why I'm doing all of this, because I know that my past me, and in a way even current me, is not capable of following along the complex way of stating things. So I'm trying to condense information without losing understandability. So to me, putting knowledge maybe on a different level, like perceiving it as a function and not as a statement, helped me. I'm not sure if it's now wrong to have this image in my mind, but it formalizes what I previously had, like I guess ChatGPT is knowledge formalized, but every function is knowledge formalized. Or not every, but function is knowledge formalized.
Functions defined by tables are not knowledge. There are different ways to define a function, with a plot, with a table, with an analytical expression. And if you do it with a function, there is no advantage in this representation.
And again, we end off the same way we begin, by not fully grasping the entire picture. Let's grasp one thing at the very end. What would you say could be a motivation to sign up for the curation grant?
I would say that basically, if you are a researcher, you have to do reviews anyway. So you can do it not just for yourself, but for the community that uses ORKG, and to try to apply semantic technologies and structured representations and to get new experience. Yeah, if I would have been a student or a PhD student, I would try to apply for that.
I see it from this perspective. We previously highly praised Wikipedia to be cultural consensus, and I guess ORKG is the closest approximation we can have for scientific consensus.
Yeah, I remember your idea that ORKG is a Wikipedia for science, and yeah, I like it. I agree.
Yes.